الصحي؟
ها.
الصرف الصحي
اي نعم.
المويه.
لا 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 لا. وست ووتر.
فين الناس؟ فين الناس طيب؟
الان حيجون ان شاء الله 5 minutes ان شاء الله.
صوتك مو مضبوط، انت ايش فيك؟ مزكم؟
لا والله تعبان.
من الصباح صوتك متغير. سلامات.
والله تعبان. وعكة كذا صحية سريعة.
سلامات سلامات. بلغ الشباب، كلم الناس، ما في احد الان. تعالوا
ايوه ايوه.
نبدا.
نتصل نرسل لهم في هذا.
ايوه
أم...
اسوي لهم تذكير، اسوي لهم دعوه دقيقه.
ايوه 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 والله.
ابو ابراهيم، السلام عليكم. مسعد الرحمن، السلام
سلام
عليكم.
سلام. هلا هلا والله ابو رايد. هلا
لا.
ابو رايد.
دكتور معانا دكتور.
ايه كلنا. ابو رايد. هذول حيسوون الجهاز اللي معانا حيسوون تجربة يستفاد منها في بدل الغسيل لما تنزل الفرق تغسل كذا على العمياني مو عارفين الشبكة. الجهاز هذا حيوفر وقت وجهد، بحيث انه يكون في زي ارسال واستقبال موجات فوق صوتية لما مربوطة بكمبيوتر بنظام. لما ترسل وتستقبل يعلمك انه في بلوكج ما في بلوكج فعشان كذا بناء على التقرير انت تغسل او ما تغسل الشبكة. ما له علاقة في السيس تي في ترى.
ممتاز
تصوير يعني.
ممتاز
فهمت.
ممتاز ممتاز.
ارسلت لهم دعوه كلهم. ابراهيم يرسل ابراهيم كمان.
مين ابراهيم؟
ابراهيم هاشم
إيه،
وماجد.
كل اي اس هم
فهد
حاطين ايميل
كاكي.
الاي اس.
حسن الشريف ونشوف.
زملاء طيب
احنا
زي
مهندس عبد الرحمن
وليد
احنا حاطين
وخالد
الاي اس كامل.
ابو ابراهيم،
سم.
الزملاء في الليل دحين نايمين زي وليد وخالد نايمين.
لا لا مو بشرط، احنا حاطينهم كل اللي يبغى يحضر للفائدة يعني.
ايوه، لو اديتهم خبر قبلها بيوم كذا
والله دوبنا سوينا لان احنا حنبدا حيكون معانا اونلاين نركب نفكك الاجهزه بعدين ونركبها وبعدين نسوي لها تيست.
الله يعني.
هاي معانا ابراهيم كويس.
ايه ممتاز. نبغى الخريف. وين الخريف؟
موظفين
دخل
حقين
طلال
الخلية.
يا ابو ابراهيم.
امم
مهندس طلال دخل.
كل الخريف الان ندق على الجمل.
فين طلال؟
لا لا طلال حق الامن والسلامه. لا خلينا نشوف مهندس محمد. مهندس محمد السلام عليكم.
Excuse me guys, we waiting others to join with us so we can start.
Yep, that's fine. We're all ready.
I'm sorry,
when
yes,
you
I'm
when you're
sorry
ready to
for
go.
late. Yes,
Not a problem. Well, hang on.
to be in one loop يعني.
السلام عليكم ابو ابراهيم.
هلا ابو طه.
ايوه حسب بدا الاجتماع، ما في صوت صح؟ ما لسه ما بدا الاجتماع هو.
لسه قاعد ننتظر الشباب الثانيين، هم يسووا لنا دعوه. الشباب ننتظر الشباب.
ماشي اوكي.
عبد الله الزهراني، فين الشباب؟
عبد الرحمن، سلام عليكم. عبد الرحمن، الله يحييك ابو طه.
عليكم السلام.
سلام. خلاص، انا اعتقد العدد
فين الناس؟
الخريف ما في حد، الخريف ما في حد منه. احنا مخليه نتكلمه، بس يعطينا شرح نظري في البرنامج حقه. وعندنا خلاص جبنا اللابتوب والاجهزه حنجيبها، نفككها اليوم ونركبها، ويحاول يعطينا موعد بكره، يسوي لنا اجتماع بكره بعد الساعه 2، يكون معنا اونلاين في طريقه تركيب الاجهزه، وننزل في السايت نسوي لها تيست. فالآن نبغى يعطينا تعريف كذا سريع عن البرنامج حقه وآلية عمله وطريقة عمله. أنا سويت له أجندة، وحول الإيميل للمهندس محمد الجمل له. فإحنا يعني لو يعطينا شرح مبسط كذا سريع عن البرنامج وكيف نستفيد منه وكيف فائدتنا في الشبكة. فهمت الفكرة؟ وبكرة يعطينا نكون معاه أونلاين، حنفكك لأن الجهاز هنا لسه جاء من الجمرك، والله ما فكيناه ولا شيء. أوكي؟
ابو زهره، يبدا الرجال ولا كيف؟
أنت سمعتني؟
اي ابدا يعني خلاص.
ايه، ويبدا ما في حد.
مين هو اللي الو يا ريتشارد؟
الحق
جود
الحق.
افترنون. ريتشارد، جود افترنون. Is my voice clear يا شباب؟ guys.
Yes, very clear. Thank you.
So shall we start introduction for what you have, the
Yep.
SewerBatt?
Shall I start with that?
Yeah.
Okay. Good morning,
Can you
everybody.
start?
I'm Richard Long, and I've been working on this project through Pipeline Surveys Limited, which is a company set up to do this particular project. And I had the idea for something like SewerBatt over 20 years ago now, and worked with academics to develop it. Set up a company which eventually had to be put into liquidation. I'll give a bit more information about that during the talk for the history. But I've been managing and contributing to the project that we're talking about today. Thank you. Chris, would you like to introduce yourself, please?
Hello.
Nice to meet you, Richard.
Hi, I'm Chris. I've been working on SewerBatt related projects since 2017. I come from an acoustics background, so I've been working on developing the technology from a sound perspective, and working out ways we can improve the accuracy and the detection of certain elements in the pipe. And I visited Medina a few months back and ran a trial with Al-Kharayev with the SewerBatt, which was very successful, I think. Thank you.
Jake, could you introduce yourself, please?
Sorry. Hello, I'm Jake, software engineer for SewerBatt. I recently did the app that you guys are using, so I'm on hand if there's any software issues.
Thanks, Jake. It would be interesting for us to know what you guys as individuals are responsible for, if that's possible, please.
Again, Richard,
Hello? Yep.
could you repeat?
So my team has introduced ourselves. I wonder whether you want
welcome and nice to meet you. My name is Abdurrahman Zahid, supervisor for the network, Sewer Network, and the STB. Okay, and Abdullah Zahrani also. Abdullah Zahrani.
Abu Iyad.
Abdullah Zahrani also is a supervisor for the network, Sewer Network, and we have also engineer Mahmoud Sagot. He's the manager of the sewer treatment plant, STB. And we have engineer Khalid Al-Malabi. Also he's supervising the STB and the sewer network. Okay, and Ibrahim Al-Nakhli, also he's a supervisor for the network. Okay, also Salim Al-Jihani, also is a supervisor for the network and the STB.
Thank you.
And also Hanis Saadi, all supervisor.
That's great.
You're welcome.
Thanks very much. Shall I continue then?
Yeah, you can continue.
Presentation. Yep.
Yeah.
Okay, I'm going to share my screen, and got an agenda that was provided by Mohammed Elmagal, which I've tried to follow as best I can. Some of it I think is just for discussion amongst this group, but for others for other parts of the agenda I've prepared some information which can be the basis of a discussion if you require. Okay, so I'm going to get into that now. And hopefully you can now all see a slide that's got SewerBatt 2 at the heading of it, which is the presentation I have. So apparently we don't have any Al-Kharayev people here this morning, is that correct? Yeah.
عبد الله ششتاوي سويت خطاب اللجنة السيفي
الخريف. Yes, there is no people from Al-Khurayf. I will invite someone from Al-Khurayf company. You can go ahead, engineer.
Yeah. Okay, so this is the agenda that I was provided with. So 5 headings, which I'm going to go through on separate slides, but basically how the system can provide a comprehensive how we can provide you with a comprehensive knowledge of this SewerBatt system and what it can do for you. Then there's this topic of the demo environment, which I think is something that needs more information from the Al-Kharayev side or from yourselves. There's going to be a presentation of the equipment working, and Chris is going to do that, and then we'll look at the training materials, and then lastly how we will be able to support you as you get the equipment into general use. And there's some things that we will definitely be doing, and then there's some things that will be options that we can discuss, which you may want to take up. Okay, so we're going to cover all of that, but I thought I'd just start with a brief history of the project. So it started back in 2002 as far as I was concerned, when I was struggling to be able to advise some of the UK water companies about the investment requirements for cleaning and repair of their sewer systems, and using the CCTV that they had available, most of which was just a one-off and didn't cover the whole of the system. I found it very difficult to come up with a coherent way of doing that, and I was looking for some cheaper, quicker way of gaining at least some information about each pipe, and had the idea of using acoustics to do that. And I then made contact with Professor Kirill Halshenko, who was then at the University of Bradford in the UK. He's now Professor of Acoustics at the University of Sheffield, which is one of our red brick universities. And the University of Bradford and myself formed an agreement to collaborate on the development, which then went on for a number of years, until in 2012 we were able to set up a company called Acoustic Sensing Technology, which was spun out of the University of Bradford, and I was appointed as the Director of Technology for that company. And our remit was to make the technology available initially in the UK, subsequently worldwide, and develop a self-sustaining business to do that. In 2017, Chris joined the company. He's, as he says, an acoustic engineering expert, and provides all the scientific knowledge about sound that we use. In 2020, 2021, Chris, Jake and myself collaborated with the University of Sheffield in something called Project ISAS, which stood for Innovative Systems for Assessing Sewer Serviceability, and that was funded by Innovate UK, which is the government's funding body for late stage research and development. That was finished in 2021 successfully, but unfortunately in 2021, with the COVID epidemic going on and everybody focusing on staying healthy by working at home, we were not able to sustain a level of income which would support the business. And by that time I was the managing director of the company, and I decided that we had to go into receivership. And in the process of that, I acquired the intellectual property from the receiver. So I can't remember the exact date for this, but I think it was 2022. I had a first meeting with some of your people and talked about the possibility of getting the technology working for you in the kingdom. In 2024, that developed into some detailed negotiations for the project, which is now just winding up. And that concluded in a project which began in November last year. And to carry out that project, I set up Pipeline Surveys Limited, and the contract is with that company. Earlier this year, Chris, as he said, did some demonstration site work in Medina, carried out a number of surveys in cooperation with the Al Kharaif people in Medina, which we submitted a report on, and I think that was a successful piece of work. And then in about August, we delivered the hardware to Al Kharaif, and earlier this week, yesterday in fact, we've installed the software, the user interface part of the tool on their computer. So they now have the full set of equipment that they can use, but that is a recent development. So that's just a little bit of background, so for those that aren't familiar. The SewerBatt 2 project, in other words the project that we're just finishing off now, sought to make some key improvements from the technology in the initial SewerBatt, and this is just a summary of the main points, and these are all based on feedback from users of the earlier tool. And so we wanted to make the sensor enclosure more robust. We wanted to waterproof the microphones. I'll just explain what that means. This green card that I'm pointing at now is one of the microphone cards, and it has 4 of these square little boxes that I'm pointing at now. That's 3 and 4, and those are the microphones. They admit air in through the other side of the card through these little holes that you can see, which lie exactly underneath the microphones. So the sound goes in those little holes, and the microphones record the whatever goes through. In the initial SewerBatt, that was how the card was put into the system. The problem is that if this was dipped into the sewer flow, these were not waterproof, so water and sewage material could make its way into the back of the microphone, and that would kill the microphone. It had to be thrown away and replaced if that happened. What we have done for SewerBatt 2 is we've applied these membranes. They're not actually Gore membranes, they're a competitor of Gore, but they work the same way. They reject any liquid and solid particles that approach the fabric from this side. They don't get through, but they are almost transparent to sound waves, and air can pass through them. So there is now a means of protecting the microphone cards from the sewage flow should it be accidentally dipped. The sensor is intended to work in air, not underwater, so it's not designed to work underwater, but we recognise that sometimes it is accidentally immersed. This should make it a lot more robust. We've also made the microphone cards more water resistant by applying a conformal coating over the back of the card. It's not totally resistant because there's still the plug here that could be affected, but probably would be recoverable by taking it out and drying it. So from that point of view, the whole system of sound collection is more robust. Then the other thing that I was very much aware of was that the user interface, the app if you like, in the SewerBatt 1 was quite clunky and difficult to use for people that weren't experts in sound. And Jake's major contribution to this project has been developing this new graphical user interface, which you'll see in a few minutes, which is I think much simpler to use, more intuitive, and altogether better. There is one thing that we set out to do that we haven't achieved, and that is developing a 3-dimensional microphone array. We got quite a long way with it, but in the end we just couldn't make it work. It doesn't mean to say it never can be made to work, but within it was delaying the timescale of the project very significantly, and in the end it was agreed that we would just use the 1-dimensional. So that's something that hopefully can be developed in the future, subject to funding.
So now, Richard, this is a microphone detecting the sound or the sound wave.
The microphone, yes, the sensor head, which you'll see in a minute, contains a loudspeaker which makes the sound, and that sound goes down the pipe, and it encounters the various things that are in the pipe, and they may or may not cause a reflection which will come back to the sensor head, and that reflection, those reflections I should say, will be recorded by the microphones. Because there's more than one microphone there, we can we know the timing of the from where the different reflections are coming from, and you'll see that in a minute.
No.
Okay, so I'm going to hand over to Chris now. I'll stop sharing the screen.
Hello. Okay. So I'll just share my screen. Okay. Can you see the screen okay?
Yes, clear.
Okay, so I've got open the SewerBatt application here. This is an app that you can use both on site when surveying pipes and also in the office to review data, generate reports and such. So when you open the app, you most likely want to set the directory in which you want to work in. So I've set up a folder called demonstration here. So we're going to use that. I currently have the sensor head hardware connected to my laptop, and it's also inserted into a 4.8 meter pipe in my garden. I'll share that image with you when I get up. But to connect to the device, I click this scan button here, which is then lists the available ports. I know that from trial and error that it's COM7. I click connect and I can press test. And then it tells me it will take up to 30 seconds. And I'll do this. And while this happens, I'll switch on the camera so you can see the current setup.
I could just add while Chris is doing that this setup procedure is only required to be done once unless the sensor head is changed for a different one.
So if I just stop sharing now, you can see the pipe of the pipe in my garden.
Can you maximize the pictures because it's a very small window we have here.
Okay. Well, I can move the camera around just to help you see what the setup is. Actually, I wasn't expecting it to be landscape. I don't know if this allows you to visualize it better. Here's the pipe.
Chris, is it possible? Chris, is it possible to share the screen of that camera?
And here's the device.
I'll ask him when he gets back to the office. I think he's not hearing me at the moment.
Connected to the laptop here. Maybe switch this off now. I'll leave it set up.
It's connected in wireless, right? No wiring.
It's wired between the sensor head and the camera.
He's not hearing us.
Okay.
It could be made wireless in the future, but at the moment it's not. Chris, is it possible to share the screen on your camera, just briefly? Because it is, we can only really see it in the thumbnail at the moment.
Yeah.
Just
Will that work? Okay, I'll see if I can get that to work. Is that better?
no, it's gone altogether now.
Is that better?
No, it's not working, Chris. Let's stop trying to share the screen, and you carry on doing the demonstration.
Okay. Sorry, it didn't work.
Anyway, there's not much to see. It's just some pipes with the sensor head put into the pipe at the far end of that picture.
Yeah.
Yeah.
Okay. Sorry, that wasn't as clear as I intended it to be. Okay. So when we want to start running a test, so the sensor's connected. It's checked that all the microphones are working. And that's this section here. So this is the RMS. This is the level it takes. And we can see all 4 microphones are working. So if we want to run a survey, we need to go to the survey tab, and we can enter in all the information manually if we like to. The operator, the site information, the pipe length needs to be known or roughly known. This is important for displaying the information. The survey and target manhole references. The pipe diameter is quite important as it will run separate processing for different diameters. Your job number, pipe ID, pipe material. You can also log the water level and any notes, any observations you can put in here. Another way to enter this information is to use the schedule. So this can be prepared in advance, where you know what pipes you're going to survey for the day, and you can put them into a spreadsheet, or you can generate these schedules in the application as well, which I'll show you here. So here's one I generated this morning. You can fill in all the fields manually here in preparation and simply select. So for this one, I've labeled it clear pipe. The pipe at the moment has nothing in it. So I press this up arrow here. I go to the survey tab, and I've got all the information here ready to go. And I can make a note here, say clear pipe if I want to, but it's already here. Any observations, and I can press start. And now I can hear the devices making a noise. I'm just going to turn off on my phone as well. So that then takes some time to process. And jumps to the results here, which is the graph of, if I just quickly explain the graphs in this tab, I like to do more surveys to show some comparisons if we have time. but this is the main plot that you're interested in when you're on site, maybe. Along the bottom, you have distance. So at 0, this is where the sensor head is. This is where you're surveying from. And then this is the distance along the pipe. As I said, we have a 4.8 meter pipe. And here you can see the device detects the pipe end, and then nothing else has really been detected at all. This table here refers to these peaks that are detected, so they're color coded so you can keep track of them. It will put each peak or each object detected in the pipe in this table, and it will label the distance, and then the user can then identify what this object is. So we know the pipe is 4.8 meters long, so we can select pipe end here. This graph here is called the energy pattern. So this goes deeper into the acoustic detail of the survey. So from this, you can look at the frequency content of the reflection that the device has detected, and this will allow us to determine what objects are in the pipe. So for instance, blockages will contain different frequency information compared to connections or pipe ends, and this is very typical of a energy pattern for a pipe end. So I'm now just going to put a blockage in the pipe, and I'll show you how the results change to that.
While Chris is doing that, I can just add that at the moment, because we don't have enough data to do it, it's up to the user to decide what these different things are that the pipe sensor is picking up. But one thing we would like to do, subject to your cooperation and the funding to do it, is to gather up all the data that's going to be collected over the next few months and use that in conjunction with CCTV to develop a system that will recognise these defects and do an automatic scoring. Chris, I was just explaining that.
May I say something, Richard?
Yes, Jake?
So yes, guys, it'd be with enough data, we'd even like to do use AI to auto recognize blockages and from the acoustic energy graphs. So the table that Chris referred to that has pipe end or blockages or laterals would be automatically filled out. That's one of the goals for the future.
Yeah, that's
Sorry,
right.
Richard.
And it would do also, it would be able to detect the size of different blockages and discriminate between those that were minor and those that required attention, and that's customizable to suit your requirements. Okay, Chris, back to you.
Okay, so I've now inserted the blockage at 3 meters. I can then go to my schedule. This is almost simulating us moving to a different pipe and then logging the information as we see fit. So now we've got all the information in. It's now the site information is now says blocked at 3 meters, and I can start the test. Now, because the system uses a certain particular sound, it's quite resilient against background noise, as it's looking at single frequencies at each particular window of time. Okay, so that's done. Now we jump to the output tab, and we can see we've got a blockage detected here. This is the added blockage I've put in. We've got 2 points detected in the peak, and we've got 2 energy patterns. So the red refers to the pipe end, this shape, and the blue refers to the blockage here. Now I'll just do put a lateral connection in, and then we can look at the review process a bit more in depth.
So now this pattern's reflecting the object what we have in the pipeline, right?
Yes, that's right. Although
so how we know is it critical or light or
well, at the moment, doing it manually, what you would do is look at the acoustic response graph, the one with the blue and red dots on it, and we're still getting a strong response from the pipe end, and that means that that blockage is not removing very much of the acoustic energy. So the judgment there would be that that blockage is not, it's a partial blockage rather than a total blockage.
And we can do it during operation, right?
You can make that judgment, yes, the person on site can do that, or it can be done later.
Okay, so I've now taken the blockage out and inserted a connection in the same place. And as you'll see to the left of the screen here, this is the folder where the files are being generated automatically. So you can see this was the first file generated, survey file generated, the second blocked one, and now the third one that we just did has just appeared.
Can you say a bit about the file naming system there, Chris?
Yes, so the file naming, this is the date but reversed so that it lists in order the time, and then it will show the manhole reference, the target, so the survey manhole, so the manhole you're at, and the target manhole reference number here, and then the 150 is the pipe diameter. And these are JSON files which I can open, and they're fully readable in terms of the metadata. So you can look at all the metadata, all the information without actually having the software, but the actual acoustic data is encrypted, so you do need to have the software to be able to read the acoustic information, the survey data, in that sense. So now I just want to talk about a little bit how you can maybe use the software in, say, the office, or if you want to review on site. You go to the survey tab and open any file that you want, and at this point you can look deeper into what you want to do. So you can select these options here. So we know that was the pipe end for our first survey. We can say, we think this pipe is clear because it's clearly got no other objects in it. So we might mark it as green. We'll say Y. We'll say pipe end visible. And then we might want to generate a report for this one, just by clicking that. And then if I open that report, that's just popped up in the working directory, and we can see a general report that will list all the information that we've entered. It will show the graphs, and it's taken a screenshot of the table as well. So that's a basic overview of the review process, and this report can be designed to your needs or to your formatting as you wish. I'll just open the blocked pipe. So what we can also do is we can add peaks or remove peaks here. So the algorithm's detected 2 peaks here, but it's good practice to select the top of the peak. And now looking at these energy patterns here on the right, The red one is related to pipe end. This one here, we know that's the pipe end because we know the pipe length, and we can see we've got this nice sort of lots of low frequency energy and less mid to high frequency energy, which is typical of the pipe end. Whereas with the blockage, if I normalize these energy patterns, you can see the shape is very different. You got less low energy and much more mid-range and high frequency energy, which is typical of blockages. If you have lots of gravel, for instance, the high frequency energy also seems to go up. That's what we experienced in Medina. So for this blue peak, we can select blockage fairly confidently, and we might say we can see the pipe end. We might say pipe end visible, but detected a small blockage, and then we can generate this report, and then we might want to also save the file, and we can just overwrite the original survey file because we haven't changed any data. We've just added some review process. Now, finally, I'll just very quickly go on to the lateral connection that we added. Again, I might want to move this peak to the peak here. We know the pipe end, so the pipe's got longer because I've added that connection, so it's showing 3 meters here, but confident that's still the pipe end, this red peak here, and this red pipe end energy pattern. If I normalize the energy patterns, you can see they're very, very similar in shape, and this is typical of a connection, an energy pattern of a connection. We get a lot of low frequency energy reflected back and not so much mid to high frequency energy, very different to our blockage. And so that's how during the review process one determines distinguishes between blockages and connections. And that's the good overview of how you might use the software and review your data. Let me know if you have any questions.
Thank you, Chris. That was good. Yeah, any questions for Chris on what you've just seen there?
Thank you so much, Chris. But what about the restoring position for this sensor? It will be in the beginning of the line, right? Upstream.
Yes. So if the sensor head is positioned at one end of the pipe, you can survey from both ends, and so you can survey upstream or downstream. And then we did this in Medina, and we would simply swap these manhole references around like this and repeat the measurement. This works particularly well for particularly long pipes, or if we're a bit unsure if they're really blocked and you want to see past more blockages, you can see past blockages, but if it's completely blocked, you can't see so far. Does that answer your question?
Yeah. What about the gases? It will not affecting the quality of the reading?
No, it's simply using acoustic waves to detect physical objects, or the reason you get a reflection in acoustics is from a change in cross-sectional area in the pipe. So if you have a clear pipe, that cross-sectional area doesn't tend to change as you go along. If you have a blockage, and the cross-sectional area gets smaller. If you have a lateral, the cross-sectional area gets bigger, and that's the general fundamental.
The density of the material will not show, to not affect. For example, because we have different density of the object.
It's not necessarily density. It's not like ultrasound, which can penetrate physical objects really well. It's more their shape there, and for instance, when I mentioned the gravel or the sand, this bumpy texture you might see in the acoustic response as more high frequency content. If you have a smooth connection, then you might see more, or that's larger, then you might see some more low frequency information. So it's all to do with wavelengths and comparable dimensions as well.
What about the maximum distance from the beginning of the to the end of that maximum distance can read?
If the pipe's really clear and doesn't have many connections, so if it has one or two connections, we were finding in Medina that pipes of 90 to 100 meters we could survey quite confidently. As the number of connections increases, the maximum length decreases. But when you get to this situation, like I said before, you can just survey from both ends.
And if I can add to that, if you can't see the far end of the pipe, that's a good indication that there's something in the pipe that needs to be attended to anyway. And that having that signal from the far end of the pipe is one of the key sort of key characteristics that are used to work out what's going on in the pipe. If you have a pipe that doesn't have manholes in it, so it might be if you imagine a pumping main, for example, that might be several kilometres long, with no flow in it, the sound will probably travel all the way along that, no problem. But it won't go through manholes because a lot of the energy is reflected back up the pipe when it gets to a manhole. So this is strictly from manhole to manhole. And typically those are not more than about 100 meters long, so for a clear pipe that's no problem at all for the acoustics, and any restriction on the acoustics would be due to defects such as blockages or a large number of lateral connections, because each of these things that causes a reflection takes some energy out of the sound that's carrying on down the pipe. So if you can imagine a number of laterals or a number of blockages, eventually there's less sound going forward to the first, then less to the second, then even less to the third, and so on, until it gets attenuated to such a degree that it's no longer going to cause a reflection at all. And at that point you lose the visibility of the pipe end. And if that is purely due to the number of laterals, you would have to say, we could do it from the other end for a start, or you may have to say, well, this pipe isn't suitable for acoustic sensing, and we'll CCTV it.
I mean, for the blockage, if we have many blockages in the line, so it will identify only the first one hitting the wave, right?
If it's a complete blockage, it will only hit the first one. What
we
find in practice, if it's a partial blockage, then some sound will go over or round it and get to the next, and so we can, as Chris is showing there, detect.
Yes, I can see here. Yeah, I see the trend.
It's something that, with a little bit of experience, that becomes quite easy to do. If you look at, are you able to maximise?
No, I can zoom in if it helps.
Yeah, just zoom in on that response graph.
A particular area, maybe around here.
Well, that's fine. Yeah, I just wanted to say that slight waviness that you can see where the blue dot is, and around it, is due to open pipe joints, which you can quite characteristic to see them evenly spaced like that and all about the same size. That's open pipe joints. So you can, with a bit of experience, you can start to read more from this just by yourself, but we think the AI interrogation will be a lot more discriminatory, sensitive.
If there is a crack in the pipeline, it will also showing here in the trend line.
Cracks, not so much. If they're fine cracks, they don't cause much of a response to the acoustics, and that's one of the reasons we talk about sewer serviceability with SewerBatt, because if those cracks had got large and had resulted in pieces of the pipe being moving in relation to the pipe, then it would detect them, and that would be a serviceability issue. But for fine cracks, which are like the start of a deterioration process, it won't pick them up.
Yeah. This device is suitable for all kind of pipe, right? Or type of pipe?
Yes, in any sort of materials, except I would say corrugated pipes. I don't know if you use corrugated plastic pipes, probably not on your foul system. But anything like concrete, clay, pitch fibre, plastic, they'll all work fine.
And GRB also?
Yes, GRP, no problem.
Yeah, assuming they're all smooth walls is key, really.
Yeah, not totally smooth. You know, the concrete is fine, because if there's a significant texture in the pipe, that will absorb acoustic energy. But not to the sort of pipes that you use for foul sewage. They're all very much the same, and they all work.
Flat, yes. If there is some up and down, it will affecting the reading. But most of the sewer line will be smooth, flat line.
Just a flat line when there's no defect, yeah.
Yeah.
Okay. Thank you.
Thank you.
شباب في أحد عنده سؤال يا شباب؟ We'll ask the other guys if anybody have questions for that previous part. شباب في أحد عنده سؤال؟
Yes, I would like to know if anything happened to the system or the machine, how we will going to have contact or what for maintenance.
I'm coming on to that. There'll be routes available, and I'll describe what they will be shortly, if that's okay. Can we leave it till that slide comes up?
Okay.
Yeah. Okay. Thanks very much, Chris. I'll share my screen again. How are we doing for time? I think this was an hour and a half the meeting was booked for. Is that I think we should be able to finish in that. I think that will give you, for the purposes of what we're doing today, quite a good knowledge of how the system works and what its outputs are. In terms of people using them on site, is this generally going to be people working for you? You're the supervisors, you'll have people out there doing this. Is that generally the way it will work? So whoever is using it, there's two ways they can use it. Basically, the way that Chris was just describing is that the operator has the competency to do some interpretation of the results that they're getting, and to set the tests up. The other way is just to have people who can competently put the thing in a pipe and press the right button. The readings are then recorded on the computer, and they can then be processed by somebody else. And that's for you to choose, make a judgment on what's the best way of employing this for yourself. And as we get the automatic interrogation working, then that'll open up other avenues. Hopefully, I mean, that was a fairly short introduction. The training course would be generally about a day, maybe a little bit shorter. But hopefully in that short explanation by Chris, you've picked up quite a lot of it. It's basically developed so that the user doesn't have to understand acoustics, they just have to be able to read the responses. We'll talk a little bit more about that. So for new users, training can be provided. That can be done by us remotely, or it can be done by somebody in the KSA, and which is probably the best way to get somebody there that can train people. But we can do it if required. And all of that information that's passed on during training is consolidated into references, and they're going to be available on a website which is being set up at the moment, which is called pipesense.net. Pipesense is a name that we're sort of rebranding SewerBatt to, but it won't be a sudden rebranding. We'll use the two interchangeably for a while. But the idea is that this is it's a little bit of a double entendre, that we have double meaning. We're sensing in pipes. Yeah, we're using acoustic sensing, but we're also, as we'll talk about a little bit more, trying to make sense of the signals that we're receiving so that they can be used for management of the system. And that's the key to the whole thing, really, because there's a lot more that you can do with this than simply just looking at it on site and giving it a score. So the sort of guidance that will exist, and what I've got here are what was made available for the SewerBatt 1 training and support. There's training material, first of all, which is basically PowerPoint slides and exercises that the trainees can do themselves using the equipment that's in their hands. Then we generally deliver each system in its box with a quick start guide. We didn't do for the two that have been delivered so far, but we will be preparing. And this is, I think it was 6 pages in this case, so it's not that quick, but it's a summary of everything that has been put across in the training, so that if any of the people on site want to have a quick check, it's there for them to do. Or it can be accessed, or it will be possible to access it through the GUI and also through the pipesense.net website. Then, as and when required, we can produce user notes. This is one of them that was produced for the SewerBatt 1, and this was just a summary of how to collect good data, just 2 pages. Again, that will be available through the GUI and on the website. There'll be a user manual, which was basically a summary of the training material, and that includes how to look after the equipment as well as how to use it, and that'll be part of the training as well. And then what we did with SewerBatt 1 was produce a few short videos that were narrated, looking at specific topics, and again they can be accessed through the GUI and online. So there's different ways that guidance can be accessed and disseminated to the users, and you may think of others and we may think of others, but those are what we were planning to do at the moment.
Engineer Richard, excuse me.
Yes.
I want to do training tomorrow, inshallah, live inside. No problem?
Have you got the materials to do that, or do you want me to provide them to you?
Online, no problem. Online, engineer.
جاتك المواد؟
اي يس
جاتك المعدات؟
جات كلها، حنفككها ونركبها اليوم، وبكره حننزل للسايد ويكون هو معنا لايف، نسوي التست.
Okay, thanks. He received the equipment, Richard.
Sorry, could you repeat that?
He received the equipment.
You've received the equipment, yes.
Yeah, and he wants you to be live with during the test.
Oh, during the training.
Yeah.
Okay. So that is Abdullah Al-Zahrani.
Yes.
Yeah. Okay. Well, we can organise that after the meeting or at the end of the meeting.
Yes, Engineer Richard. Same time tomorrow, inshallah.
Same time tomorrow. Yes, that'll be fine. That's the 29th. Chris, I don't know whether you're able to be present. Are you? Or have you got other things arranged?
From yes, so from 11, I might be able to make that work. Yes, I just need I will need to check a few things. I need to be somewhere. So yeah, I might be able to move it. That's no problem.
That'd be good if you could. Thank you. Okay, but yes, I'll be there at 11 o'clock tomorrow. Right, then the next thing I didn't really understand was to provide a demo version of the system, and I wasn't sure what this was, whether it was to have demo software or demo hardware as well. So I really need further information about that. Is anybody able to provide clarification for us? No? Okay, well, I'll have to go back to Mohammed El-Gamil on that one. I think we'll leave that then for now, move on. Then the next set of topics was to have explanatory videos, which I've already mentioned. Yep, we can do that, and we can record them so that they can then be accessed. That can be done. I'm asking the question though who to do. We can because obviously if we do them there's going to be time involved and we need to be able to account for the cost. The videos can then be hosted on the website when that's ready, which will be by about the beginning of next year, and they can be made available through the user interface for use in the field as well. So yes, all of that's possible. Direct participation and supervision of field training activities. Okay, well we've just agreed that I'll do tomorrow, and can do others as well if required. And then provide computers or laptops for trainees. Now, we didn't include any funding in the current project for doing that. So I know that Alcarof have bought one very recently, and that Jake has installed the software on it. If you want to do that with other computers, laptops, and you provide the laptops, that'll be fine. So I'll wait to be advised on that score. Excuse me. So digital training materials, I've just summarised those really in the slide last but one. So most of that slide is just a repeat of what I've already said, but it'll be a suite of appropriate material. Question of support. The current project included support for 3 months from delivery, so we could say 3 months from today, well 3 months from, so that would be November, December, January. It would end in January, so happy to extend that, but there will be a degree of additional cost involved to do that, and that the quantum of that cost would depend on what level of support you require. But my proposal for that is as follows. So a communication channel, and that will be by email and a support platform. So, but principally by email. There'll be an email using the domain of the pipesense.net channel. It'll just be support@pipesense.net. But after the 3 months is up, then we'll need to talk, or before the 3 months is up, we'll need to talk about what levels of service Do you require somebody to be available sort of more or less immediately within an hour, say, or next day? Or luckily our business days are fairly similar. There's only 2 hour or 3 hour difference at the moment, while we're going through the winter, and then a 2 hour difference in the summer. But anyway, there are ways that we can do that, and we can develop that in consultation with you. Mechanism for reporting malfunctions and difficulties, well, that can be the support email. It's the best way of doing that, I think. Device warranties. The contract, we've given a 2-year warranty for manufacturing defects, so it won't cover sort of deterioration due to use. And our experience of these sensors is we're putting electronics into a fairly hard environment, and they do have a limited life, but they can be renewed as and when required, for a cost obviously, but it wouldn't be the full cost of starting again. It would be just the cost of replacing the sensor head. But there will be a period during which they're repairable, and our plan is to provide a stock of spare parts for you to use in KSA. And my proposal is to include the following. So microphone cards, because although they should last longer now that they're protected from water, they still are the most vulnerable component. So 20 of those, 6 of the foams that protect the microphone card. The foams can be washed out and dried and reused, but they have to be open cell foam, and that's so that sound can actually get through them. That also means that water can get through them as well. So they're a bit like a sponge. They'll if you put them underwater, they'll soak up all of that water, but that water will equally quickly run out, although it may leave dirt behind. So washing them out and drying them is generally good enough to keep them going. And microphone cards and foams can be replaced by the user either on site or at the depot very easily. So they don't, as long as each user is carrying a spare of each of those, and we provide 2 microphone cards and 2 foams in each set that goes out, so the users have a spare with them on site. So this 20 and the 6 foams are intended to be back at base, sort of locked in a cupboard somewhere, but that can be accessed when required. Then if anything else goes wrong, it'll be most likely with the sensor head, and it might be due to some damage. Maybe the cable connection's been damaged, or the loudspeaker has become unserviceable or something like that. But all of those components are not user serviceable, so it would be necessary to return the sensor head to us here in the UK, and it can be refurbished and returned. So the suggestion there is that there should be 2 sensor heads in Saudi, which are available to swap out if one of the ones that you're using becomes unserviceable, to keep you so that you can remain in production all the time. And then a stock of miscellaneous small items like clamp screws and ball feet, which tend to get detached from time to time. So that's the initial proposal. If during, you're welcome to comment on that, but if during experience of using them you think you should have other things available, then we can sort that out. And then, so all of that will be included in what you've paid, But there are further possibilities for giving you technical support which haven't been included in this initial project. But I would suggest you have a think about these. One is to set up the automated serviceability assessment. That would be using the data that you will have, both the acoustic data and CCTV data, letting us have access to that. And then we would use various signal processing techniques, including artificial intelligence, to process that data and develop rules which would then be written into the user interface so that the system can make assessments of serviceability automatically. The user will still be free to override those if they wish, but that would help. We can't do that at the moment because this is a new sensor head and we need data from it to be able to do that. So that's one thing which we could talk about. The second one is this where data is collected on site by your people but made available to ourselves in the UK, who can provide a checking service and our own serviceability assessment if you wish. That can all be done by putting the files in the cloud somewhere so that we can access them. It would be quite easy to do, and maybe of interest to you. And the third thing there is a database where all of this SewerBatt data that you're collecting can be stored together, and there's a whole aspect of SewerBatt there that I haven't really talked about yet, and that is that there's more to it than just that first survey that you do in the manhole. Because it's quick and cheap to use, you should be able to, over a period of time, extend SewerBatt surveys to many of your pipes, certainly all of the ones up to about 300 millimetres, which is the vast majority of them. And by putting them all together, it's possible then to have a system which can automatically make suggestions and plan out repeat surveys, because some of these pipes that are SewerBatt surveyed will need to be scheduled for resurvey at some point in the future. In other words, they're showing signs of deterioration, but not to the point that they need any intervention at the present time. You go and SewerBatt them in a certain period, maybe 6 months or a year or whatever you choose. You can see whether they're actually deteriorating or not. Because one of the projects that I did a few years ago now was to go back to the same about 50 different sewer pipes in Yorkshire in the UK and survey them with SewerBatt every 2 weeks and look to see how their serviceability forecast was changing. And that was quite interesting in that some were serviceable and didn't change at all during that period, whereas some you could see a progressive change, and in others they might change quite sharply. And for example, if you think of a sewer system which has got upstream pipes that are collecting sediment, and then it rains heavily, which it does in Yorkshire, and I guess it does sometimes in Saudi, but perhaps not as often, that sediment can be mobilised and moved around the system, moved down the system where it might settle out again. And so you can get this quite quick change in serviceability. And by having all of this SewerBatt data in one place and being able to interrogate it, you can build up those sort of plans for action, better understanding of how the whole system is working. Okay, so that is, well, it's worked quite well for time. We're nearly at 12:30 here. What would be 3:30 for you, I guess. Any more questions on what we've just been through before we round up?
Yes, I have a question. Can we run the device immersed inside the waters.
Can you run the device
full of pipeline full of water?
No, you can't. It won't work underwater. So if you've got something that's completely blocked, you would have to go to the other end of the pipe, or the other end of where the blockage is. But you would then be able to determine actually where the blockage is by finding where the pipe ceases to be full of water and SewerBatting up from that dry end. But
yes.
Yeah, but the system doesn't work underwater. It's not designed to. Doing acoustics underwater is a whole different thing, because in air the acoustics don't couple with the pipe material. They just go down the tube as if it's a waveguide, whereas when they're underwater there's much more interaction. This is Chris's field, so maybe he could explain it better, but basically just take it that no, it doesn't work underwater.
What about the minimum
The minimum air gap? Well, just enough to get the sensor in. So the sensor is 100 millimeters diameter, so you need 100 millimeters air gap as a minimum to get it into the pipe, and it has to be inside the pipe, not just in the manhole.
Inside the pipe, the beginning of the pipe.
The beginning of the pipe, that's right, yeah. Because that way the system knows that all of that acoustic energy is being put into the pipe by the excitation system, whereas if you have it in the manhole, the acoustic energy is just going to sort of spread out in the manhole, and some of it will go down all the different pipes, but you don't know how much. Yeah.
So we need to center the device to the middle of the circle, right?
I'm sorry, could you just say that
so
again?
We need to the position of the device to be in the center of the pipe.
Ideally in the centre, yes. Sorry, I understand. So if the whole of the pipe end is dry, or just a little flow in it, go for the centre of the pipe, the axis, and have the sensor lined up with the axis, so it's pointing straight down the pipe. But if needs must, if there is more water in the pipe, then you can fit it into the airspace, then that's allowable as well.
Because all the time what we have here, there is minimum flow, and there is a flow waters inside. Maybe a little bit of flow inside the line.
Yeah.
So I don't know.
Chris, can you just comment from your experience in Medina to what extent flows in the pipe were an issue?
Generally, I think we encountered maybe one or two where the pipes were full. Other than that, we could get the sensor head in most pipes. I would say around 95%, and I think we did about, I can't remember how many we did.
Getting on for 100 it was.
Getting on for 100. And one thing to note is that if we couldn't get in to the pipe and the flow was too much, it was just logged, and in a way you do a observational survey there for future checking or cleaning or whatever is deemed suitable. So it didn't feel like a full waste of time getting that manhole up and just looking in there as well.
And were those, when the pipe was full, was that because it was flowing full or because it was blocked downstream?
I think it was mainly blocked. I wasn't always fully aware of what was happening. It was a case of the manhole went over and they said they couldn't get in, so I didn't get the full information, but I think it was I got the impression it was because there was an issue.
I could point out here that as well as doing the acoustic test, the fact that somebody goes to the manhole and can look down it, they should record anything unusual that they can see. So if there's a lot of sediment deposited on the benching, or there's rags hanging off the step irons, that can go into the record as well. And we can add fields for that if it's useful at some point, to record that sort of information. Now,
you.
I should have mentioned this at the beginning. Apologies for not doing so, but I have been making an attempt to record this meeting so that I can look back over it and pull out the points for action. And I can make this recording available to you. In fact, as long as you're happy for me to do that, I can send a link out.
Okay. Engineer Abdullah, he asked about the maintenance of the machine.
Yes, you'd like me to talk about the maintenance? Yeah.
مهندس عبديلة. مهندس عبديلة.
ايوه السلام عليكم. تفضل ابوي.
انت سالته عن الصيانه، بس شوف ايش تبغى تساله.
لو صار اي حاجه كيف اتواصل معاهم، كيف
ايوه
كيف
خلاص كلم شو ايش يحتاج ابو بيشرح هو عشان المينتنس.
كيف ايوه كيف نسوي صيانه، وكيف لو صار عطل يتواصل مع مين، لان هم كافراد ما هم كشركه. انا بعرف الكونتاكت نمبر حق الشركه وليس كشخص.
تكنيكال سبورت قصدك؟
تكنيكال سبورت بس لشركه كاز كمباني not as a person.
He asked about the maintenance engineer Richard about the machine. If we have problem or trouble in the machine, how we can contact them? There is some technical team can support us.
Initially, you can email me at the email address I use for my general purposes, which I'll copy through, or I'll give it to you now. It's richard@rjlong.co.uk. But in the fairly near future, there will be this other email called support@pipesense.net. And that email is actually working now, although it's not, the website isn't up, but the emails do work. So I'll make sure that you get that as well. So that'll be how you can contact me. In terms of routine maintenance of the equipment, the main thing is keeping it clean. Fairly on in Chris's presentation, he showed you, when he was looking at the utilities tab, there were 4 dots. They were all green on the screen that we were looking at, and those are the condition of the microphone cards. And if say one of the microphones was to become blocked, that to a serious degree that would go red. Here we are, Chris is going to show us. Yeah, so in this particular case, something's happened to microphones 3 and 4, and they've gone red in this picture, but also there's a message box popped up to draw that to your attention. And basically, if that happens, it's a question. You have to replace the microphone card. They're not serviceable once that's happened. But with the waterproofing that we've now got, and with the some care by the users, it shouldn't happen commonly. It should only be a rare occurrence. We shall find out. Okay. Other maintenance, not a lot to do, really. Just, I think it is fairly obvious if the cable gets damaged, but as long as it keeps working, then it's okay. Yeah, I think that's it. Chris, would you add anything to that?
I guess it's worth mentioning the telescopic pole. It's fairly trivial to replace parts on that. They get knocked around a bit. I think that was included in your presentation, the spare parts for that.
Yes. And again, the new ones can be supplied if necessary, but I would anticipate that they would last a reasonable length of time, unless there's some accident. If they get run over by a van or something, then they might get broken.
Engineer Richard, the availability of the spare part, it will be in the stock, because I don't know, here in Saudi Arabia you need to order it from outside the kingdom, right? If there is, we need to order the spare part. It is how long it will take to reach, or is it available in your area?
There will be some in the kingdom, and I went through the list. It was a fairly short list, but there will be microphone cards, there will be foams, and there will be 2 complete sensor heads, and then some knobs and things for the poles. So a fairly brief list, but they'll be there so that you can get access to them quickly. How many depots are you going to have this system working out of, do you think? No?
Allah, I don't know exactly, but my point is, if you want to order the spare part, is it easy to get it quickly, or you need to make, it will take a long time to provide to us?
Well, we've got limited stocks of everything at the moment.
Limited stock. Okay, that's what we want.
Yeah, the thing that we're shortest of at the moment is the printed circuit board that's inside the sensor head, and we have to get some more of those made. We'll be getting some more microphone cards made. The sensor bodies are not. We've got a few of those. When I say a few, I mean 1 or 2 of those available, but they're not difficult to make, quite quick to make. But there's a small quantity of everything in stock at the moment, so it would only take as long as it takes. Once I've got your email, as long as it takes for me to pack it up and post it by whatever means gets to you the quickest. So it should be a couple of days turnaround, I would have thought, unless these things get held up in customs. I don't know.
Okay, thank you so much, and nice to meet you. On my side, don't have any question. If other people have question. يا شباب، واحد عنده شيء؟ عنده سؤال يا شباب؟
Okay.
شبيبة.
Yes, thank you very much for joining. Okay, so Abdullah Al-Zahrani, yes. Shall I send a link then that we can use tomorrow? For
Zahra Abdullah Zahrani.
This is for the training that Abdullah Al-Zahrani is doing tomorrow, that he wants me to join. We'll sort that out, don't worry. Okay, then shall we close it there? If nobody's, yes. Well, thank you all very much for attending, and look forward to working with you in the future. Bye for now.
Thank you, and nice to meet you. See you.